Hello students, great to see you again. In this video, I'm going to show you step by step how to solve the circle problem. These questions are picked from the tutorial books. This is the questions. So we notice that the circles that we want to form is in the first quadrant and they touch the x-axis, y-axis and the straight line 3x minus 4y minus 20 equal to 0. There is a fixed point lie on the straight line. First, we are going to find the equations of the circles. After that, we are going to find the length of the tangents from the straight line to the circle, and we are going to find the equations of other tangents from the point F to the circles. The hints given is that the formulas of the perpendicular distance. Okay, so that means that after this, we are going to apply this perpendicular distance to solve our problem. Before we start anything, let us illustrate the information in the diagram first. So we try to draw the diagram. The circle, we touch x-axis, y-axis and the straight line 3x minus 4y minus 20 equal to 0. And there is another tangent. Okay, we touch the circles. Okay, so first of all, from the information given, so how are we going to form the equations of circles? So we're starting to form the equations of the circles based on the information given and the diagram. So since the circle is touched the y-axis and x-axis, so we have the radius here and here r. So which one is the perpendicular to the axis? So we can say that r equivalent to h equivalent to k. So we can say that the center CHK is equivalent to r and r. Okay, so after that, we are going to find the r. So by using the perpendicular distance, so we can say that the r is equivalent to the absolute of 3r minus 4r minus 20 divided by square root of 3 square plus minus 4 square. So we will have the minus r minus 20 divided by 5, whereby this is equivalent to 5. So we try to solve this absolute inequality. So we have the minus r minus 20 equal to 5r, or minus r minus 20 equivalent to minus 5r. So we have the 6r equal to negative 20, so whereby the r equivalent to negative 10 over 3. For this, we will have the 4r equivalent to 20, so r equal to 5. Okay, since the r is in the first quadrant, or r is the length of the circles or radius, so the r should be greater than 0. Therefore, we just accept the r equal to 5. So the center will be 5 and 5. Then the equations of circles will be x minus 5 square plus y minus 5 square equal to 25. Okay, we try to transform into the general form. So we have the x square plus y square minus 10x minus 10y plus 25 equal to 0. In the part B, we are going to find the length of the tangents from the F to the circles. So this is the length that we are going to find. That is the length of the F is the length of the tangents from the point F. So we may apply the theorem Pythagoras. So let's say we're going to find the length of CF first. So step 1. So we find the length of CF. And step 2, we apply the theorem Pythagoras. So the length of the tangent, that is the df, will be equivalent to the square root of CF square minus the radius square. So first of all, So step 1, so we find our CF. So we use the formula of distance. So just now in the file part A, we already know your C is 5. So we use the formula of distance. So 12 minus 5 square plus 4 minus 5 square. So we are going to have 7 square plus 1 square. So we have the set of 50. And we proceed with your length of tangent. So therefore, so the length of tangents, that is the df. So this is our step 2. So we apply the theorem Pythagoras. So the CF is the set 50 square. Subtract with the radius. The radius is r, is 5, so 5 square. So we have the 50 minus 25. So we have the square root of 25. So we have the 5 units as our length of tangents. In part C, we are going to form the equations of another tangent from the point F to the circus. So let us draw the other tangent from the point F, touch the circus at the point E. So this is the line. So we touch the circle at the tangent, so at the point E. So this is the radius. This how we find the length of the tangent is also 5. So here we touch the tangent is the radius, so this is also 5 and 5. So that means that saying the CD equal to the CE, equivalent to DF and equivalent to EF, so equivalent to 5. So that means that the DF is perpendicular to DF. So this one and this one is perpendicular. They are perpendicular to each other. So therefore, to form these equations, so we may use the gradients, equations of gradients from the tangents 3x minus 4y minus 20 equal to 0. So we rearrange this. So we have that y equivalent 3 over 4x minus 5. So that means, so this is the gradient. So the m df equivalent to 3 over 4 and the m df will be the minus 4 over 3. So because the df is perpendicular to df, so therefore the equations of line df is given by y minus, so we use the point E, so is 4 equivalent to the minus 4 over 3 x minus half. So we arrange to have the 3y minus 12 equal to the minus 4x plus 48. So we have the 3y plus 4x minus 60 equivalent to 0. So this is the equations of another tangents. So this is how we solve the circus questions. Hope you understand what I have done.